Good morning, everyone. Today we are going to discuss about the concurrent processing. So the concurrent processing means more than one programs are executed at the same instant of time. Now to execute more than one program at the same instant of time, we need more than one CPUs. So in a uniprocessor system, it is not possible that more than one instructions are executed at the same instant of time. So for uniprocessor system, the uh, meaning of concurrent processing is completely different from the multiprocessor system. In uniprocessor system, more than one programs are executed in an interleaved manner. That means some part of one program is executed, then the CPU will switch from one program to another program, then some part of that another program will be executed. And in this way, the CPU will continuously switching from one process to another process and until all the programs are executed. So this is known as the concurrent processing in terms of uniprocessor system. However, this concurrent processing may generate the inconsistent result in case of uniprocessor system. We will explain this with an example. For some example, we will consider two programs, P1 and P2. These are the two programs. So P1, what the P1 will do? P1 will simply increment a variable, increment the value of a variable, whereas P2 will decrement the value of another, the same variable. So suppose, uh, suppose the value at the beginning, the value of counter equal to 7. Now, here there are two processes, P1 and P1, P2. P1 will increment the value of counter, whereas P2 will increment P2 will decrement the value of the same counter. So if P1 will be executed first, then P2, or the P1 will be executed first and then P1, whatever be the sequence. Uh, After the execution of P1 and P2, the counter value of the counter will remain same, that is 7. Now, uh, suppose there are six instructions. The S1, S2, and S3 are the part of P1, and uh, S4, S5, S6 are the part of P2. Now, as we know that in uniprocessor system, the programs are not executed at the means two programs are executed in interleaved manner. So some part of P1 will be executed and some part of P2 will be executed. So for some example, if we for this example, if we consider that S1 will be executed first and then S2, S1 and S2 of P1 will be executed at first, and then the CPU will switch from P1 to P2, and next two instructions such as for S4 and S5 is executed for P2, and then the CPU will switch again from P2 to P1. This time it will execute S3, and after that it will again switch to P2, and if it executes S6. So if this in this order, if the uh, uh, instructions are executed, then we will find the value of the counter will become 6. And if another order of execution, if we consider, for example, S1 and S2 will be executed at first, then S4, S5, S6 will be executed, and after that S3, it will execute the S3 instruction of P1. If in this order the programs are executed, the instruction of these programs are executed, then we find the results will become 8. So the problem that occurs in the concurrent processing is that the output of the program will not depend on the program itself, rather than it will depend on in which order the instructions are executed. So different order of executions can give you the different results, and this is known as the race condition. So due to the concurrent processing is basically introduced to enhance the CPU efficiency. However, we find that in concurrent processing, there is a chance that data inconsistency can occur. So whenever, so at this particular instance of this condition, which is known as the race condition, we don't want that this race condition can occur. We want that the results should be correct. However, in concurrent processing, there is a chance that different order of execution can give you different results, and this need to be stopped. So this is an example of a critical section problem. In next class, we will discuss on the critical section problem.